Thank you so much for the opportunity to present my research today. I'm Himani, and I will be a rising senior at Dublin Kaufman High School. And so, for the past 2 years, I spent my time researching, simulating the effect of turmeric on the growth of E. coli in bacteriostatic and bactericidal mechanisms. Um, so, at the time when I got really interested in this research, it was a common theme in the news to hear about outbreaks where people would get sick from consuming contaminated lettuce that had E. coli in it. And so, doctors were actually not prescribing antibiotics to treat those infections because they could have further complications. And so, I wanted to find a solution to this problem without exacerbating the antibiotic resistance crisis. So I wanted to look into using natural antibiotics to see if they would be effective to both cure those symptoms, but also to see if they could be used to prevent the E. coli from contaminating the lettuce in the first place. So, the natural antibiotic that I chose to research was turmeric. And my initial research question was looking at how effective turmeric was at both curing and preventing the growth of E. coli. And then eventually I modified that research question to see if prevention or through a bacteriostatic mechanism is more effective than curing through a bactericidal mechanism. So, just for some background, 42% of E. coli infections are caused by E. coli contaminating leafy produce such as lettuce or spinach. And how the E. coli actually can contaminate the produce is because in places like California and Arizona, where lettuce farms are typically, there are also cattle ranches that are right next to them. And so inside cattle's small intestines, they actually have E. coli to help them digest the food that they eat. And so cattle feces also has that E. coli in it. And that feces can run off into the common water supply, which is then used to water the crops. So that's kind of how the E. coli contaminates the romaine lettuce. And then again, E. coli has been identified as a priority pathogen by 3 federal agencies, and 9 million Americans do contract diseases from foodborne pathogens. So, in my research, I wanted to test if using turmeric as a cure and as a prevention for preventing the growth of E. coli. So, for my alternative hypothesis, it was that if the E. coli is already present and turmeric is added to that, then the growth of E. coli will decrease. And that was the cure mechanism. And then for the prevention mechanism, I hypothesized that if turmeric is already present, then the amount of E. coli that is able to grow will also be reduced. And then everything about the experiment was controlled, about the petri dishes, and they all started with the same amount of E. coli. So I actually made my own turmeric extract. I used raw turmeric root and isopropyl alcohol because that was the only readily available chemical that I could use to extract the curcuminoid molecules, which is actually what has the antimicrobial property in turmeric. And then the petri dishes in both the cure and prevent mechanisms were inoculated with 25 microliters of that turmeric extract, and the control just had isopropyl alcohol and no turmeric. So how I measured the growth of the E. coli was using a sheet of grid paper. So I put the petri dishes on top of the grid paper and counted the number of squares that the E. coli filled up on the grid paper, and then I was able to use that to do some analysis and calculate the square centimeter growth area and percent growth of the E. coli. So as you can see from this graph here, the blue is the control, so just the E. coli, and then the red line is the prevent mechanism. So on day 0, that dot shows where I inoculated on the first day, and then the cure mechanism on day 1 is when I inoculated it. So in the cure mechanism, the E. coli was able to grow by itself for the first 24 hours. And you can see at the end of the 10-day experiment, both the prevent and cure mechanism did have a lower average end growth. And I forgot to mention that each of these data points is actually an average of 8 data points. Um, So you can see that while both of them were effective compared to the control, at the end, the prevention mechanism was still the most effective because it had the lowest average end growth. So I did two t-tests. One was comparing the control and prevention mechanism, and that was statistically significant. And then the other was comparing the control and the cure mechanism, which was also statistically significant. Um, and then that prompted me to be more interested and try to more accurately simulate the post-harvest processing of lettuce and compare that to if turmeric was going to be used as an antibiotic regimen and if doctors were going to prescribe it on like a daily dose. So I wanted to redefine the mechanisms and continue my research for another year, where I actually renamed the prevent mechanism into the bacteriostatic mechanism, and the cure mechanism became the bactericidal mechanism. And so my new hypothesis was that the new mechanisms, the bacteriostatic mechanism, so preventing the E. coli growth by preventing the E. coli from contaminating the lettuce in the first place, would be more effective than waiting for someone to consume the contaminated lettuce and then treating their symptoms. And then again, I changed my method and I used an edible turmeric extract just to make the simulation more accurate because isopropyl alcohol is not safe for human consumption. Okay. And then, so this is just showing how I redefined the mechanisms. So in the bacteriostatic mechanism, I actually had the 2-week period, and this is simulating how long lettuce lasts. So the first 2 weeks after harvest is typically how long it takes for lettuce to spoil, and the first 3 days is typically how long it takes for it to be processed. So every day of the first 3 days, I inoculated the bacteriostatic petri dishes with 10 microliters of the turmeric extract. And then the bactericidal mechanism is actually simulating a different 2-week timeline. So in this one, on day 0 is simulating when you would eat the contaminated lettuce, and then about a 6-day incubation period before you start showing symptoms. And then on day 7 is when you would be prescribed turmeric to try to cure your symptoms. And then from day 7 to day 14, every day, a dose of the turmeric antibiotic. And so that was also an inoculation of 10 microliters of the turmeric extract. So here you can see again, each of these data points is an average of 8. And in this, on day 14, you can see that the bacteriostatic mechanism did have the lowest average end growth, and the bactericidal mechanism was still effective, which was consistent with my previous research the previous year. So you can also see that while the bacteriostatic mechanism had the lowest average end growth, it also used the least amount of antibiotic, or the lower amount of antibiotic. And this is especially important because, especially now, the antibiotic resistant crisis that we're experiencing, it's important, and doctors are being advised to use less antibiotics, but we're still maintaining or improving the effectiveness of those antibiotics. And so in conclusion, I actually did do another statistical validation and compared the bacteriostatic mechanism and the bactericidal mechanism to each other. And that was also statistically significant. So in the future, I'm really interested in continuing some microbiology research and testing if E. coli will eventually become resistant to turmeric. And I'm also interested in investigating simpler and more accurate methods of measuring bacterial growth using things like a spectrophotometer or the serial dilution method, as well as the Kirby-Brower zone of inhibition test, which could actually be used to compare turmeric to some other well-known prescription antibiotics. And finally, I would like to thank my teachers, Mr. Raybould and Mrs. Parker, for helping me with my research and for making it possible. I would be happy to answer any questions.